Alright, we can see on screen the 5 basic volume formulas we're going to be taking a look at, or at least the categories we're going to look at. We're going to deal with prisms, cylinders, spheres, pyramids, and cones. And I've kind of listed them in the order that I have, partly because prisms and cylinders pair up really well with each other, and pyramids and cones pair well with each other. Spheres sort of stand by themselves a little bit. They are connected because there are circular components to cylinders and cones, but otherwise, I just wanted to point out a couple of things as we go along. Now, prisms are the ones that most people tend to be familiar with. Prisms can be something like a cube because it has these kind of square faces here that we're working with. If you take into account the poor drawing here, this might be more like a rectangular prism as opposed to a cube. Although a cube is a rectangular prism. You could also have things with a triangular base, and it kind of goes back like this. Now, it's not the best drawing in the world, but that's the general idea. The big thing with prisms is that they have a rectangular set of faces. They have 4 rectangular sides, so the top, the bottom, the left, and the right. And then the front and the back of this thing would be the base of the figure. And so for this one, the intention was that the base is a square, which would make it a cube. In this case. But if that base was a square and these sides were really long, if these were really long boxes, then they would be rectangular prisms just because they don't actually follow square sides all the way around. Here we have a triangular prism because the base is a triangle. So we use the base to kind of name the figure. Personally, I feel like cylinders should have been defined to fall under prisms, as they are, in my opinion, circular prisms, but that's not a formal thing. Prisms are defined in a way that excludes cylinders, so they're their own category. To find a prism's volume, though, you just take the area of the base, that's what big B is going to represent, and you multiply it by the height. And this is where a lot of people get length times width times height. Because for a square or a rectangle or a parallelogram, you do use like length times width, or a little base, little height. So it's worth noting here that B is the area of your base. And remember that the base is going to be, again, the part that is non-rectangular for most of these prisms, although a rectangular prism has rectangles for all sides, but it's the pair of sides that's a little atypical, a little abnormal. The reason I like grouping cylinders is that the base of a cylinder is a circle, and the area of a circle is pi r squared. Well, we see that show up times the height here, so the volume formula for a cylinder really is just big base times height. So if you can remember that prisms and cylinders pair up really well, then all you really need is this formula. This one actually applies to both prisms and cylinders. Cylinders are just kind of like a special case because they're a different type of shape. So this right here, just again, I'll make a note, this is the area of a circle. Now, a sphere stands alone a little more. Unfortunately, it sort of has a strange formula that requires a little extra talking about to get to. We're just going to make a note here that it's not too bad to remember if you can keep up this weird 4/3 part of it. If you remember that it's weird and that it has the 4/3, the rest of it makes sense. Because the circumference of a circle has pi times r, the area of a circle has pi times r squared, so the volume formula that deals with circular figures, a sphere, is pi r cubed. So we're working in 3 dimensions, so r ends up being cubed. Now, pyramids are based on triangular shapes. And we know that in 2 dimensions, a triangle is 1/2 a parallelogram. Well, it turns out that pyramids, because we're in 3 dimensions, end up being 1/3 of a prism. A pyramid is going to be 1/3 big base times height, where this B up here, or this B down here, is the same as this B definition up here. It's the area of your base. All pyramids have some sort of base. It could be a triangular base, it could be a square base, a rectangle, just like we had up here, but it tapers off in a way that creates 1/3 of the actual volume you're used to seeing. Now, you can imagine that if cones compare to pyramids in the same way that cylinder compares to a prism, then actually it will turn out that this is 1/3 pi r squared times your height, where again we see pi r squared showing up to take the place of our base, because a cone is very much like a pyramid with a circular base. So these are the basic volume formulas that I'll be working with in future videos. Nothing too crazy here. Remembering base times height, it shows up almost the entire way through. And then just keeping up with the 4/3 on your spheres and the 1/3 on your pyramids and your cones.